Hey, welcome back. I'm actually recording this video right before you guys get to math class, so hopefully that'll keep it nice and short. So today we're going to jump into graphing linear equations, and this is some big boy math, of which I'm really ready for you guys to jump into as well, and this is exactly what you're going to be doing next year, so it will hopefully make the beginning of high school much easier. So as we always do in these rap journals, is let's underline our essential question. How can you recognize in a linear equation, how can you draw its graph? We have recognize and then at least how to draw a little bit of its graph. So first actually we're going to draw, and then we'll see how after we've drawn some how easy it is to recognize. Now it says here work with a partner. That'll be me. And together we're going to graph a linear equation. Now they give you a nifty little coordinate plane, or Cartesian plane as you may have heard it called, to use. But first what we're going to do before we go down there is it says use the equation y equals 1/2 x plus 1 to complete the table. Choose any two x values and find the y values. So it says choose any x values, any two x values, and then find the y values. So x gives us a choice, and then when we're done with x, we'll see what y is. Now, I'm going to choose some easy numbers because it's math. Let's not make things more difficult than it has to be. We do that in everything else in our lives. So I see here that it's going to be 1/2 times x, or 1/2 times whatever number I'm going to choose, then plus 1. I want an easy answer, so I know that 1/2 times 2 is going to be simple, so I'm going to choose 2 as my number. 1/2 times 2 is just 1, and then 1 plus 1 is 2. Well, that's cool. And we can choose negative numbers too, so I'm going to go -2 because that's also easy. So let's do 1/2 times -2 is going to be -1, and then -1 plus 1 is 0. Now we choose a value, and then we choose an x value, then we find what the y value turns out to be. So now it would like us to write the two ordered pairs given by the table, and these are called solution points. So let's write those two ordered pairs. We can write them right underneath of our table. Is we have 2 is what we chose for the x, and then y is what it gave us. So that's one solution point, and then we chose -2 as our x, and it spit out y as 0 for our second coordinate point. Let's now plot the 2 points, drawing a line exactly through the 2 points. So we have this nice handy graph here, and it would like us to plot these 2 points. That's easy. So let's go over 2, up 2. For our 1 point, and for our second point, let's go over -2, 1, 2, and up 0. So we have 2 dots there. We've plotted those points. Now we can, which we'll do later, is we'll start plugging any point in, and we'll see where all those dots line up. But they want us here just to only use 2, it's the bare minimum, and then draw a line exactly through these 2 points. So if you see here, I grabbed a line and I made a perfectly straight line and put it over this. I want you to use a straight edge when you do this to make sure that we have straight lines. It'll be much less confusing if you can draw a straight line through all of this. So make our points a little bit bigger so we remember where they are. Now it says find a different point on the line and check this point, that this point is a solution to the equation y equals 1/2 x plus 1. So we're going to choose a random point here. Hey, what if we choose, this is an easy one, 1. Right here, we go over 0 and up 1. Now if we plug in those values into our equation, we have x is over 0, so that's 0. So we have 1/2 parentheses times 0 plus 1. So let's do the math. That's y over, and on the left, y should equal 1. We'll put parentheses, 1. 1/2 times 0 is 0 plus 1, or just 1 equals 1. We found a point, and we took its coordinates, we put it in this equation, and it came out as true. See how this point falls exactly on the line? Now, do we think that this is true for any point on the line? If any point on this line is a solution. So if I go and I pick this point here at over -6 down -2, or if I go all the way over here and choose, see this point, over 4 up 3, or over 6 up 4, do we think that all those points will make this equation, the y equals 1/2 x, true? So if you're not sure on that last one, what we can do is we can choose 5 additional x values for this table, in positive and negative, and then we'll plot the solution points, and then we'll see what happens. So I know a few numbers I want to choose that are really easy. -6 is easy because it's an even number, and an even number times half or divided by 2 is easy to use. -4. We did 1. We did that one already. We saw what it was. No sense in doing it twice. Let's do 4. If we did in the negative, we can do the positive for both of these. So, -6, 1/2 parentheses -6 parentheses plus 1. Half times -6 is -3. -3 plus 1 is -2. Hi, Keith.
You're not talking to yourself, are you?
Not yet. Okay, Keith is gone. Let's sub in -4. Now, it's always important to use our parentheses when we do this so we don't get our negatives mixed up. -4 plus 1. Half of -4 is just -2, and then -2 plus 1 is -1. Yay! Now, if you would do the remaining ones, sub in the x value and see what y value it gets you. Circle these. Now you'll see we made it back here, and let's plot our values. When we plug in 1 for x, we'll get 1.5 for y.
Look how creative an idea this is.
That poor meter stick never knew what was coming to it. Yes, you look like an intelligent supporter for Gary Johnson. If you plugged in +4, you should see that you got +3 for y value. If you plugged in +6, you got +4 for y value. All the way down here, when we did -4, we got -1 for our y value. When we plugged in -6, we got -2 for our y value. So now, do we think it's true that any solution point of the equation y equals 1/2 x plus 1 will land on this line, on this straight line that we plotted? Please explain. Lastly, for this example, we need to look at y equals ax plus b, a linear equation. Let me help you here. When these letters x, y, and x, those will forever be there. They are always your variables whenever we plot these equations, because we have our x and y coordinates. So those are actual numbers that we'll put in there. Now, a and b are constants. That is, whatever number is next to a. So in our example equation, when we had 1/2 x plus 1, a would be your 1/2, and b would be whatever number is being added or subtracted to it. So a, whatever number is next to x, and b, whatever number is being added or subtracted to it. So please tell me here what a means and what b means. Then lastly, why do you think it's called a linear equation? A linear equation. A line-making equation. Why do you think it's called that? And write that here. Define linear equation. Last thing today is about our friend here, Rene Descartes. Yes, that is pronounced Descartes, not Descartes. It's French. French dude, and he really pushed us over the edge with this type of math. Because before in math, all you had were terrible ways to write long equations, and you never had any way to look at an equation. And so this is the guy that really took the idea of the coordinate plane or Cartesian plane and ran with it. Because this is the first time that people could see solutions of an equation. So you didn't have to work with a purely symbolic point of view, but you could actually draw things. So if you're someone who believe, you'll see, I have to see it to believe it, think Descartes. So what he did is he found a way to represent all of these types of equations to draw things. So that lines had a certain equation, that parabolas, that circles, ellipses, and so on. All these things he found a way to represent through math. And it's because of this that we can have anything from animation films to anything we have on a computer, to everything that we have here that we use in technology is because of these planes, or is because of these equations, these algebraic equations that represent all of this. So finally people are able to use this to discover calculus, which is super complicated math. However, in this we're going to just study linear equations. When you get to Algebra 1 and Algebra 2 with Mr. Claus, then you'll start learning about other types of equations. So we're doing linear equations, or line, and we will be working with this form. Nothing fancy. All it is a number times x, or dividing x, and then plus or minus another number. A parabola would have this x squared right there. We're never going to work with that this year, so don't worry about that. And then circles, both x is squared and y is squared. And we're not going to worry about those either, because that gets super complicated in calculus. All we're doing here is worrying about lines. So as the last thing I want you guys to do is, how can you recognize a linear equation? What things have you noticed, and how can you draw its graph? What method did we use in the beginning here to draw the graph? We made a little table, we subbed in any value for x, and we found the value for y, so write that out. And then write an equation that's linear. Make one up. Have some fun. And then write an equation that's not linear. So it would be either a parabola or a circle or something like that. And lastly, if you're a visual learner, most people can learn math a lot more easily when they see pictures of the math. So for you, how is Descartes' invention of the Cartesian plane or the coordinate plane, how is that important to mathematics and to you? I will see you in class tomorrow. It's like I timed the bell for that. Wonderful.